Okay, so since you already have the notes, because that was your homework last night, I want you to go to page 27. Try and work out number 1. Okay, read through. Try and work out number 1. I'm going to give you a few minutes to work it, and then we'll go over it together. Okay, let's go ahead and go over number 1. If you're started on number 2, go ahead and stop for a second. Number 1 says, a recipe for 1 batch of spice mix says combine 3 teaspoons of mustard seeds and 5 teaspoons of chili powder and 1 teaspoon of salt. How many batches are represented by the diagram? Explain or show your reasoning. What did you do, Afton? Okay, so for 1 batch of mustard seeds you saw, or 1 batch takes 3 teaspoons of mustard seeds, so you counted 1, 2, 3, that's 1 batch. 1, 2, 3, that's 1 batch. 1, 2, 3, that's a 3rd batch. So there's 1, 2, 3 batches of mustard seeds. Then what? Jake? Okay, on the chili powder seeds, how many do we need for 1 batch? 5. So we count out 5. 1, 2, 3, 4, 5. That's 1 batch. 1, 2, 3, 4, 5. 2 batches. 1, 2, 3, 4, 5. 3 batches.
I just circled like
Okay, that's fine. So the next one is 1 teaspoon of salt. So 1 batch, 2 batch. So then, yeah, I saw a lot of you kind of doing this. Okay, the only thing you have to be careful of is sometimes, let's just talk about at home. What is the likelihood that you have exactly 9 teaspoons of mustard seeds? And you probably have some left over, so just be careful, okay? Because you might have enough for 4 batches of mustard seeds. Yeah, but maybe you don't. Maybe you just have 2 of these left, so you don't have or even if you had this, could you make a whole nother batch if you have 2, 2, and 1? No. So just be careful circling everything. And again, that's fine, but just pay attention to make sure there's not any extras tacked on there.
Yeah, so if there was 3, 2, and 1, would you only circle those 3 because that's not a full recipe?
Yeah, so you would still say only 3 batches because this would just, and if you're explaining, you could say you can make 3 batches and you would have 2 teaspoons of mustard seed and 2 teaspoons of chili powder left over. Oh yeah, 3. Sorry, I got one in my box there. Okay, does that make sense? Now, in the upcoming sections, it's going to talk about changing the batch. So let's say you're like my husband and you like stuff to be spicy. How could you alter the recipe to make it? So again, make the recipe. If you're like my husband, he would taste it and be like, I want it spicier. You would add more chili powder, okay? What if the original recipe, you taste it and you're like, ooh, that's too spicy? What could you do? You would take out some chili powder, or Dom's saying you could add in more of the other 2. Are both of those correct? No. Either reduce the chili powder or add extra of the other 2.
But if you put too much salt, it's going to taste bad.
But if you put too much salt, it might be too salty. It might be too salty as is, so you would have to decrease the amount, okay? So that's what we're getting into, is not only setting the ratios, but then deciding what would happen if I changed one of the numbers. Okay, so kind of understanding what the numbers are. Luckily, you guys have a lot of background knowledge in food. Leo. Yeah, there could be half a teaspoon. Yeah. Okay, moving on to number 2. If you haven't already started it, I want you to start number 2. I'm going to give you a few minutes to work. If you finish number 2 and I haven't started going over it, what do you think you should do?
Wait.
3.
Start on number 3. Okay, let's go ahead and go over number 2. Priya makes chocolate milk by mixing 2 cups of milk and 5 tablespoons of cocoa powder. Draw a diagram that clearly represents 2 batches of her chocolate milk. Jake, help me out.
You have to, so like you have to put 2 like squares of.
Okay, so he's saying put 2 squares. Okay.
And then another 2 squares and another batch. And then 5 circles for cocoa powder.
Okay.
And then
What else do you have on yours? What else do you have on your picture?
I just circled.
Okay, he circled, showing that this is one batch and this is one batch. I agree with all of that, but Jake would lose a little bit of points if this was a quiz. And he said it, but he doesn't have it written on his paper because I can see his paper. Owen, what's he missing?
The label.
The labels. He said a square to represent chocolate milk. But if I picked up his paper and it looked like what's on the board, can I see that? No. So we would just write that this out here, just write chocolate milk and use the label. What is the label for chocolate milk? Cups. And then the circles are representing cocoa powder. And what is the label for my cocoa powder? Tablespoons, TBSP, or you can write it out if you don't know the proper abbreviation. Okay?
Because you're making chocolate.
Cocoa powder.
Yeah, but you said chocolate.
Yeah, you said chocolate milk.
Oh, sorry, you mean the label up here? Yeah, okay, so that's milk. Sorry. So the label is just milk. So one batch, let's use our common sense brains here for a second, but sometimes we don't think about it. How much chocolate milk would one batch make? How much chocolate milk would one batch make? Tatum? 2 cups. So easy, it's hard. Okay? Why would one batch make 2 cups of chocolate milk? Leo? Because you have 2 cups of milk, and when you put cocoa powder in it, does that make more milk? No, it just, what's it called when it dissolves in there?
Mixture.
What'd you say?
Dissolves.
He said mixture, I think, right?
Oh, it's
It's not a mixture, but it's like, a mixture is like a solution. Good job. A mixture is like Chex Mix where you can re-separate it. Solution is where it mixes in and you can't separate it. Like, kind of like Kool-Aid, lemonade, chocolate milk, those are all solutions. Because once you put the cocoa powder in, if you put too much in, you can't just pull cocoa powder back out of it. You have to add more milk.
Yeah, it's kind of water soluble.
Yes. Okay. Raise your hand if you're already done with number 3. Or sorry, raise your hand if you're not done with number 3. Okay, so I'll give you a minute to work on number 3. If you're done with number 3, just keep on working through. We're going to get through them all.
to work on number 4.
Yeah, if you just keep. Okay, we're going to move on to number 3. In a recipe for fizzy grape juice, the ratio of cups to sparkling water to cups of grape juice concentrate is 3:1. Find 2 or more ratios of cups of sparkling water to cups of juice concentrate that would make a mixture that tastes the same. Okay, for it to taste the same, you have to have the same ratio. And we're going to add in how many batches you're making. Okay, so if you didn't write that, that's fine because it didn't ask for it. But usually I ask you for one that would taste the same and tell me how many batches you're making. So Lily, what did you do?
6 and 2.
Okay, how did you come up with that? Okay, so let's start with the original ratio. Let me move this up. Start with the original ratio. What was my original ratio, Lily? 3 to 1. What were my labels for that 3 and that 1? Okay, and notice when I do these, I always put just a generic label. Why do you think I would do that? Hallie? Yeah, so you know which one is which because the number one error on these is you flip them. Okay, you'll give me the labels backwards. So if you write them, you're less likely to get confused on which one's which. So that's for one batch. Lily said she multiplied both of those by 2 and got 6 over 2. So should her answer be 6 over 2? No, her answer should be what? 6. Keep going. 6 what to 2 what? 6 cups of juice. Hold on. Okay, so with these, the answer is not 6 to 2. It's not wrong, but if you give me 6 to 2, I'm gonna put minus 4th. What does that mean? Okay, that means that 6 cups of what? Sparkling water. 2 cups of grape juice. Okay, who had another one? Who had another one that works? Hallie?
I had 12 cups.
So you multiplied them both by 4? Okay, so 12 cups of sparkling water, 4 cups of grape juice. Okay? You could have multiplied them both by 3 and got 9 to 3. You could have multiplied them by 5 and got 15 to 5. By 6, got 18 to 6. Could have multiplied them by 10 and got 30 to 10. Okay, there's lots of different answers here. Now, part B, get rid of my part A. Part B says, describe another mixture of sparkling water and grape juice that would taste different than this recipe. If this was my creation, I would have put, and tell me how it would taste different. So I want you to take a second and tell me how it would taste different on yours. We're still on 3B, other page. I want you to tell me, like, how would it taste different? Because you should have numbers down, but I want you to tell me how would it taste compared to the original recipe. How would it taste different compared to the original recipe? Okay, so who has a ratio that would taste different? Dom?
I did 6 to 4.
Okay, 6 to 4. So this would be times 2 on top times 4 on bottom. So he put too much what? Grape juice. How would that affect the taste, Dom? Yeah, it'd be more grapey, okay? That's what I want you to think about is how would it affect the overall taste? So yes, that would be too much grape, okay? But maybe he changed it because the original recipe wasn't grapey enough for him. Okay, Jake, what do you have?
It'd be like more.
What was your number?
I just said 3 over 1.
3 over 1 is the original. So you want it says describe another mixture. Hallie, so copy down one of these if you. 3 over 2? Okay, and that's the same thing. So as Dom's, that's actually an equivalent ratio to Dom. So it would still just taste a little bit extra grapey. Tatum? Do you have another one?
I was going to say 3 over 1.
3 over 1 is what we were given. So that was the original recipe.
6 over 2.
What? Okay, 1 over 3. So 1 sparkling juice to 3 grape juice. Okay, what happens if you taste the original recipe and you're like, ooh, that's way too fizzy? Who can give me a ratio that would correct the recipe, make it taste better to me if the original was too fizzy? Elise?
Put 2 over 2.
Yeah, 2 over 2 or even 2 over 1. We're going to keep the grape juice the same and just decrease the fizziness, or Elise even tried to up the grape and decrease the fizzy. Would that also result in a less fizzy drink? Yes. Owen? Could you do 3 over 3? Yes. That would just mean for every cup of grape juice, you do an equal cup of sparkling water. Okay, let's move on to number 4. We're getting into number lines and double number lines. Dom. How can we figure out the missing parts? Leo?
So in 18 to 30, we have to see what plus 18 will equal 30.
Okay, or if you can't figure that out, you can always do it backwards. What is 30 minus 18? What is 30 minus 18? 12. Okay, and now that 12 is broken into how many equal parts? Hallie? 2, because I can see there's 1 part right there and 1 part right there. So I'm going to divide this by 2. What's 12 divided by 2? 6. That means it should be, and I'm showing you the process because pretty soon it's not easy ones like this. There's harder ones. Okay, but that process always works. So that means we should be counting by 6. So 18 plus 6 is what? 24 plus 6 is 30 plus 6? 36. Go ahead and let's check it. Plus 6, do we get 42? Yes. Once we figure out our pattern, it should be consistent all the way through. I'm just going to keep on going through. That one. At the kennel, there are 6 dogs for every 5 cats. The ratio of dogs to cats is blank to blank. Ethan, what'd you get for this one? Dogs to cats.
I got 6 to 5.
6 to 5, I agree. B, the ratio of cats to dogs. Dawson?
Cats to dogs. 5 to 6.
5 to 6. C, for every blank dogs, there are blank cats. Emmy? Okay, for every 6 dogs, there are 5 cats. D, the ratio of cats to dogs is blank to blank. Owen? 5 to 6. What is the only difference between B and D? Leo?
B has 2, the word 2, and D has the colon.
Yeah, B has the word T-O, 2, and D has the colon, but you say them the same. Okay? Number 6, moving back to Jake's favorite unit, geometry. Alina has 80 unit cubes, blocks. Okay, she has 80 blocks that are all cubes. What is the volume of the largest cube she can build with them? How do we find volume of a cube? Volume of a cube. Leo? Okay, side length cubed. Side length cubed, which means side times side times side. But all of those numbers have to be the same. And I have to get a number. I'm going to write less than 80. Why would I write it like that? Yeah, 80 is the biggest number that answer can be. Okay, you could have put equals 80. And then your best bet is probably to guess and check. So let's start with 5. What's 5 times 5?
25.
Times 5.
125.
125. So can my side length be 5? No, that's too high or too low?
High.
Too high. So let's go down. Let's go down to 4. What's 4 times 4?
16.
Times 4?
64.
64. Is that under 80?
Yes.
Yes. So the volume, this has to be 4 times 4 times 4, which is 64. Cubic units. Okay? Because if I went any bigger, I would need to have 125 blocks. Okay, and I don't have 125, I only have 80. Now, the next one is almost so easy, it's hard. Notice all of these problems. 3 times 1/3, 10 times 1/10, 19 times 1/19, a times 1 over a. That one might be a little confusing. What kind of problems are all of those? Leo?
Like where you can just take the whole number.
Well, let's just look. We're looking at the problem.
Yeah.
3 and 1/3. How are those two numbers related?
It's just
Jake.
like if you put it 3 over 1.
How are 3 and 1/3 related? Ethan, do you know?
Same thing. It's just
It's not the same thing, but they are related how, Owen?
if you do that times 3, it'll
I don't want answers. How are 3 and 1/3 related? Dom? They do both have 3s, I agree with that. What about 10 and 1/10? 19 and 1/19? What are those things called? Those are related. They're reciprocals. 3 and 1/3 are reciprocals. That's where you flip it. 10 and 1/10 are reciprocals. 19 and 1/19 are reciprocals. A and 1 over a are reciprocals. When you multiplied this one out, okay, if you look at it this way, I'm going to go ahead and put it over 1. If you haven't worked this one yet, I want you to do that same. Cross cancel. Look diagonal both ways. What happens? Yeah, they all cancel out. But when we cancel them, do they disappear? No. What do they become? They become 1s. So really we have 1 times 1 over 1 times 1, which is 1 over 1, which is 1. If I do this one, same thing. Everything kind of cancels out and it would become 1. What about the next one? 1. We have not worked with variables at all. It's the same thing because A and A would cancel out because it's the same thing, so they'd cancel out and become 1. So let's go to the other side now. 5 times what equals 1? Owen? 1/5. F. Meyer, what do you think F is? 17 times what equals 1? 1 over 17. Good job. Last one, Afton. 1 over B. Now, this was actually teaching you a rule by just showing you examples. So I want you to write this rule. I want you to write any number times its reciprocal. I don't know how to spell reciprocal. I or an O there. Reciprocal, I think it's actually an O. Any number times its reciprocal equals 1. It doesn't matter what number you have. If you multiply a number by its reciprocal, which remember reciprocal is where we flip it, you will always get 1. It doesn't matter what the number is. If you take a number times its reciprocal, you will always get 1. Dawson, have a seat. Yes. Okay?
It has to be a unit.
Yeah, a unit fraction. Okay, you guys do not have homework over the weekend. Bring your book on. Have I dismissed you yet? Okay, make sure you have your books with you on Monday.